Isomerism. Okay, so this isomerism, today we studied that there is a structural isomerism. Structural isomerism. Okay, so in generally there is a another one part, there is a stereoisomerism. We will study that in next video for that stereoisomerism. Actually, the structural isomerism, the organic molecules, the structural arrangement is only can be changed. Okay, so iso means there is a same molecular formula, the different structure, that is a isomerism. So what are that structural isomerism? First case, there is a chain isomerism. Chain isomerism. And second category, there is a positional isomerism. Positional isomerism. And there is a third there is a ring and chain isomerism. Ring and chain isomerism. Okay, yes. Then next, the fourth category, that is for functional group isomerism. Functional group isomerism. Okay, the next, the fifth for metamerism. Okay, so metamerism. And the sixth category, that is for tatamerism. Tatamerism. So this topic is covered for that majority of the organic question, especially for GOC. So you must be listen to very carefully in this video still end. Okay, so let's see that one by one. The first category, that is for chain isomerism. Chain isomerism. This chain isomerism, the chain length only can be exchanged. Okay, so for example, see the methane molecule. If the methane is not in the chain molecule, but this cannot be so that the chain isomerism. And next, the CH3, that is a ethane. This also cannot be sourced in the chain isomerism because this only two carbon. Then suppose see the CH3, CH2, CH3. This also cannot be given in the chain isomerism because these only three carbons are presented. So this methane, ethane, and the propane cannot be used in the chain isomerism. So the essential of the chain isomerism start in that hydrocarbon, that is a butane. Very good. CH3, CH2, CH2, CH3. That is a butane. Okay, or that is for N butane. It's a chain isomerism. What? Yes, that's a CH3, CH3, CH3. Okay, so this numbering 1, 2, 3. So the second carbon as a substituent methyl. So that's why that's a 2-methyl propane. Okay, so this name, actually the N-butane and the 2-methyl propane, such as both has a same molecular formula. Okay, so but the chain length is different. So similar like any molecule, if it presented, that is under the category of the chain isomerism. Okay, okay, done. The next, the positional isomerism. Let's see that the positional isomerism. Okay, the positional isomerism, the substituent or that functional group position can be exchanged among that molecules. Just it is interchanged the substituent or that functional group position in that molecule. Okay, for example, ethylene, CH2 double bond CH2, ethylene. We cannot say here that's a positional isomerism, and that CH3 CH double bond CH2, that's a propene. So this also cannot be whether there is a double bond first carbon or second carbon. Whatever that, these two molecules cannot show that positional isomerism, especially for alkene. Then next, the CH3 CH2 CH double bond CH2. Here there is a butene. Yes, there is a butene. It shows that the positional isomerism, because see this double bond are presented 1, 2, 3, 4. There's a first carbon. So that's why this name as a but-1-ene or butene. Okay, that's a one is understood. That's why it's most of the time we can say there's a butene like that. So it's a isomerism CH3 CH double bond CH3. What this name? Yes, there's a 1, 2, 3, 4. The double bond are presented at the second carbon. That's why there's a but-2-ene. Very good. So these two, it's a same molecular formula, but it has a pi bond position. It's a interchanged. So that's why similar like that any molecules. Actually, here double bond as a functional group. Anywhere the substituent or that functional group are interchanged among its a molecule with a different IUPAC name, that is came to the that positional isomerism. Okay, very good. Okay, next, the ring and chain isomerism. Ring and there is a chain isomerism. This ring and chain isomerism, the two component, it has a ring as well as a chain compound. Yes, see the CH3 CH double bond CH2. So this name is a propene. Okay, it's a propene. Because we cannot say here there is a the double bond numbering carbon. Okay, so because one is understood, that's why there's a propone. We cannot say like that. So here there's a propene, there is a enough. So this is a chain length, chain isomer. It's an isomer of a ring. The CH2 single bond CH2 single bond CH2. Okay, so that is nothing but for cyclopropane. Okay, here the number of carbons is C3, hydrogen as a H6. Okay, C3H6. See 1, 2, 3, 3 carbon, 2, 4, 6 hydrogen. So it's a molecular formula, but it shows in the two different isomers. One is a propene, another one is a cyclopropane. Okay, propane. So similar like that molecules is showing that isomerism, that is under the category of ring and chain isomerism. The next category, that is for the functional group isomerism. Yes, there is a functional group isomerism. That functional group isomerism, actually the functional group means in that molecules they have more reactive wherever that group are, that is a functional group, or functioning of the chemical reaction which group or which part of that molecule, that is called that functional group. Okay, for example, here one isomers or has a different functional group compared to that another isomers. For example, the CH3CH2OH. So here is a functional group as alcohol. Okay, so its isomers what, CH3OCH3, very good. Here is a functional group what, that is a ether as a functional group. So the same molecular formula but the different functional group, that's called that functional isomerism. And similarly the CH3CH2CN, that is a cyanide or nitrile, it's a isomers CH3CH2NC, that is for isonitrile. So this functional group and this functional group are in the different category, so that's why these two are the functional isomerism. And also again two examples, the CH3CH2COOH, here is a functional group as a carboxylic acid, and similarly H C double bond O CH2 CH3. So here is a functional group as a ester. It's a acid as a functional group. Here is a ester as a functional group. Okay, so that's why the kind of molecules are called, that's a functional isomerism or functional isomers. Okay, so similar like that, a lot of the examples is there. If you have any doubt, you can comment in this video. I will clarify, or I will give more clarity for upcoming videos. Okay, then next isomers, actually that is for what, yes, that is for metamerism. This is a metamerism. This metamerism is nothing but the same functional group but different compound, so that is called that metamerism. So whatever that the functional group cannot be changed, but the entire compound name can be changed. There is a same functional group but different compound, that is for that the metamerism. Okay, for example, the CH3 CH2 C double bond O CH2 CH3. So this is a functional group for ketone. Actually this name IUPAC 1 2 3 4 5, there is a 3 oxo or pent 3 one, there is a pent 3 one, this is IUPAC name, pent 3 one. And its isomers what, there is a CH3 C double bond O CH2 CH2 CH3. Here IUPAC name 1 2 3 4 5. Here also there is a pent, but here is a 2 one. So this pent 3 one and pent 2 one, they have the same functional group of ketone, but entire compound IUPAC name are the different. So that's why that is for that under the category of the functional group isomerism. Okay, let's see that last isomerism, such as there is a tautomerism. Okay, so the final part of that in this video we will study now, that's for that tautomerism. This tautomerism is dependent on that the alpha hydrogen. Okay, so for example, there is a tautomerism is depends on that alpha hydrogen. Okay, alpha hydrogen is dependent on that. So generally the tautomerism cannot be existed. Okay, where that cannot be existed, if we clearly understood, then the tautomerism occurred place we easily learn out. Okay, so there cannot be possible places, there cannot be possible place or position. The tautomerism cannot be possible position. Actually the first category for that bridge head. Okay, bridge head alpha hydrogen cannot be existed. And then the second category, that is for that the yes sp2, or that's a sp hybridized carbon of alpha hydrogen, that is also cannot be exist. Okay, and there is a alpha hydrogen third category, alpha hydrogen is equal to 0. These kind of molecules are cannot be shows that the tautomerism. For example, see, remaining all molecules are showing that the tautomerism. In the case of tautomerism, there is a the sigma bond is converted to that pi bond. The sigma bond is converted to that pi bond. That's why the sigma electrons is converted to that pi electrons. So similar like that questions sometimes is asking in the NEET and JEE. Okay, for example, the CH3 C double bond OH, whether this molecules is showing the tautomerism or not. Okay, there is a ketoenol tautomerism and generally. So this is for that the aldehyde form, or here representing the CH3, it's for that ketone now. So this functional group is substituted carbon, that's for alpha. Here there is a 3 hydrogen, and here also 3 hydrogen, totally 6 alpha hydrogens there. So we have conclude that alpha hydrogen is must, but that alpha hydrogen if cannot be presented in that bridge head high carbon as well as sp2 and sp hybridized carbon, so that both the two category not exist for in this acetone molecule. Okay, in the mechanism point of view, one hydrogen I can representing, or I can written in that position. So now this bond is situated here, this bond is go up. So what are that CH2 double bond, there is a COH, that's CH3. So there is a ene, carbon carbon double bond is representing ene, OH is representing all. That is nothing but enol tautomerism. Okay, so that is for that keto and enol form, keto and enol form. So both these two, the keto form is most stable. That's for that the stability order. Okay, so the keto form is most stable compared to that enol form. In generally, the keto enol tautomerism is very very important. For that topic is nothing but just we go to that where that keto enol tautomerism is not possible. Like that we must be clearly understood the remaining anywhere that is possible to that tautomerism. In generally where that not possible, yes, bridging alpha hydrogen and sp2 or sp hybridized alpha carbon of alpha hydrogen cannot be existed, as well as that alpha hydrogen if not or if equal to 0, alpha hydrogen is equal to 0 or constant, that kind of molecules, these kind of molecules cannot be showing that keto-enol tautomerism. Okay, so remaining all molecules which exist as a keto-enol tautomerism. In generally, compared to that the stability order, there is a keto form as a most stable compared to the enol form. If only one case the external stability of that intramolecular hydrogen bonding, if it's possible for enol form, there only there is a enol form as a most stable. Okay, so otherwise the keto form as a most stable. Okay, I am mostly satisfied for this in this video, because you very easily clear in this content. If you have any doubt, you can comment in this video, and if you like this video, like and subscribe and share your friends. Okay, thank you to all.